So let's do another problem. Let's start by doing number 6 on page 433. I know I'm kind of going backwards, but that's okay. So with number 6, we have the integral. We have the integral of t squared plus t squared over 9 plus t to the 6th dt. Okay? Now, this one's a little bit tricky. So what I want to do is show you what will happen here. There's a couple of things I could do. I could just as easily let t equal t cubed, or let u equal t cubed, and then do a substitution this way. That's one way to do it. So let's do it that way. And get rid of the t squared that way. Or I could let u be t to the 4th, and then d left over with the leftover t, which makes it that much more complicated and have to do like another substitution. So it gets to be relatively tricky. So, but I'm going to use the slightly more obvious substitution here of u equals t to the 3rd. So we're going to use some algebra to rewrite this problem. It's t squared over 9 plus parentheses t cubed to the 2nd power, like this. Right? Remember the rule of power of a power. So I'm going to write it like that. Now that I have done it this way, I can see the substitution that I'm supposed to use. So let's take this function and put it back into the integral. So this is going to become the integral of t squared over 9 plus parentheses t cubed squared, like that, dt. Now the substitution becomes really obvious. So the substitution will be u equals t to the 3rd. And then taking the derivative of that, we end up with du. Du is going to equal to 3t squared dt. And then dt is going to equal du divided by 3t squared. You'll notice I'm showing you the step where they cancel, because sometimes people just start immediately substituting back the whole expression for dt, and they make a mistake when they do that. So let's do that substitution. Integral t squared over 9 plus, that becomes a u squared times, of course, du divided by 3t squared. T squared goes away. 1/3 comes out because it's a constant. So 1/3 integral of 1 over 9 plus u squared du. That is a completely simple integral, which we don't need to look up on a stupid table. And so this becomes 1/3 times 1/3 arctangent of u divided by 3 plus c. Everybody see that? So using the formula for arctangent, you could look this up on the table, but why? Nobody looks this up on the table at all. So 1/3 times 1/3 is 1/9, obviously. So we end up with some ugly expression of 1/9 arctangent of u over 3 plus c. Now we have to change that u back into t, and of course I let u be t cubed. So since I let u be t cubed, it therefore becomes something like that. Okay? So since u is t cubed, we'll change it back to t, so this becomes 1/9 arctangent of t cubed over 3 plus c. Everybody got it? Not too bad. So that integral of 1 over x cubed plus a squared is going to equal 1 over a arctangent of x over a plus c. That's where I got the formula from, okay? Very good. Now, let's shut up and do another problem.